Next example, dia suruh kamu construct the Born-Haber cycle and determine the lattice energy of NaCl. Okay, kalau let's say ada perkataan Born-Haber cycle, ada lattice energy NaCl, that means you kena buat lattice energy formation of NaCl. Apa maksud lattice energy formation? So you write down the thermochemical equation of the lattice energy NaCl. Okay, di mana 1 mole of a solid ionic crystal is formed from its ionic gas. Okay, Cl minus gas. And enthalpy lattice ni yang kamu kena cari. Okay guys, the first step that you need to do ialah please label all of the enthalpies given. Okay, and the first one you know that this is the enthalpy of formation. Okay, and next ialah enthalpy of sublimation or as known as atomization. In this case, since Na ialah a metal element, so it's going to be atomization for metal Na. First ionization energy of Na ialah di mana Na ni dia dapat positive single charge, okay, Na plus. Enthalpy of atomization of Cl ialah enthalpy of atomization untuk non-metal elements, and lastly ialah electron affinity of Cl di mana Cl dapat charge negative. Okay, memang dia tak bagi kamu thermochemical equation here, so you need to build the thermochemical equation. That's why I told you guys it is very important untuk you guys hafal all of these enthalpies punya definition, so that kalau you tahu dia punya definition, you bolehlah tulis dia punya thermochemical equation. Contohnya, enthalpy of formation of NaCl bermaksud 1 mole of NaCl is formed from its elements. Okay, you know that Na elements dia ialah in solid because Na berada di group 1, isn't it? Cl2 non-metal, Cl ni element dia must be in non-metal punya elements which is in gas. So kalau gas dia tak boleh atom, dia kena molecule, so that's why dia jadi Cl2. So you balance kan, Cl ada satu kat sini, ni ada 2, so you need to times it with 1/2 here. Okay, so that balance. So dah balance, okay, done. Next is enthalpy of sublimation of Na ataupun enthalpy of atomization untuk metal element. Kalau atomization untuk metal element, usually you nak tukar dari metal element tu daripada solid state kepada gas state. Okay, sebab atomization ni, that by definition maksudnya when 1 mole of a gaseous atom is formed from its element. Okay, element Na memanglah solid. Okay, so that's why kita nak jadikan dia up to 1 mole of gaseous atom. Alright. Next ialah ionization energy. Okay, maksud ionization energy ni ialah bila daripada Na gas ni, daripada 1 mole of atomic gas, dia jadi ion. Okay, sebab dia release elektron. Tapi nanti kalau dalam equation tak adalah kamu nak kena tulis plus elektron kan, kalau kamu dah buat energy cycle file ni. Alright, so basically ionization energy ni ialah bila 1 mole of atomic gas ni dia dapat positive charge because dia release electron. So next ialah atomization energy untuk non-metal elements. So basically kalau non-metal elements, it usually in gas phase, and kalau in gas phase usually memang dia di dalam molecule, so that's why you atomizekan this Cl2 so that you can get 1 mole of Cl atom. Okay, this is Cl atom in gas phase. Alright, lastly is electron affinity. Electron affinity of Cl ni di mana you akan form 1 mole of negative charge ion, okay, from this non-metal elements, because kenapa dia accept electron here. So basically electron affinity ni ialah bila non-metal elements tu dia dapat single negative charge. Okay, the last step is to build the Born-Haber cycle untuk find the lattice energy, okay, according to file cycle, where you have to put your target equation ialah you punya enthalpy of formation. So this is the thermochemical equation for the enthalpy of formation we have built before, and turun bawah in this case ialah enthalpy of atomization for metal element, and this is the thermochemical equation for the enthalpy of atomization for a metal element. Okay, betul tak ni? Betul lah, sebab kita dah buat before this. So senang, kamu just bawa turun je macam tu, bawa keluar je. Ini pula ialah thermochemical equation 1/2 Cl2, and then you akan dapat product Cl gas kan. This is enthalpy of atomization for non-metal element. Okay, and then this is ionization energy untuk non-metal element, where you will get a positive charge for metal element, and this is the enthalpy. This is thermochemical equation for the enthalpy of electron affinity untuk non-metal element, where you will form a negatively charged Cl here. Okay, and lastly is your thermochemical equation of lattice energy. Okay, di mana 1 mole of solid ionic crystal is formed from its gaseous ions, and this is something that you need to find. Okay, so dalam soalan, kalau you ever wondered what is the pemakahan of all of this, okay, let me tell you lah ya. Okay, usually, okay, bila you buat enthalpy of formation with the correct, okay, you kena make sure with the correct thermochemical equation, correct phase, correct energy, okay, this whole thing, okay, this whole thing baru 1 markah. Okay, lagi satu atomization. Okay, dia akan tengok satu persatu tau. Okay, kalau you dapat the correct thermochemical equation untuk atomization energy ni untuk metal element daripada solid ke gas ni, okay, 1 markah. Kadang-kadang setengah markah je ni. Kadang-kadang dia tengok dua-dua ni dengan ni baru 1 markah. You bayangkan pemakahan dia kat situ. Okay, yang ni pula student selalu dapat salah in this case. Okay, you jangan risau. Ni memang apa tu, thermochemical equation untuk enthalpy of atomization for non-metal elements, where half Cl2 you akan dapat product Cl. Kalau you dah build you punya all of the enthalpies yang disebutkan ni, you would be it will be no problem lah. Okay, it will be no problem because you dah build you punya thermochemical equation before this, so you just nak check it out, betul tak? Half Cl2 dapat Cl ialah enthalpy of atomization. So kalau dua benda ni betul, and also you tulis, kena tulis tau energy ni, tulis energy yang betul, simbol yang betul, okay, and then amount yang betul, baru 1 markah. Kalau tak dapat markah langsung. Okay, yang ni pula pun biasanya kadang-kadang the pair of this 1 markah. Okay, dia akan check. Okay, ni daripada Na gas dapat Na plus gas, and this is what? This thermochemical equation belongs to the enthalpy of ionization energy untuk metal element. Okay, so kalau dia check ni betul, and then with the right label here, okay, dengan you letakkan, masukkan value, baru 1 markah, tahu tak? Okay, from here to here, 1 markah. Same goes to here as well. Okay, dia akan check, is this the correct thermochemical energy for the electron affinity? Tengok ni, daripada Cl gas dapat Cl minus gas, and it must be 1 mole. Tak boleh bawa 1/2 kat sini, kena 1 mole. Okay, you tengok balik you punya tadi kita dah build sama-sama thermochemical equation for electron affinity, betul tak? Daripada 1 mole of Cl gas kena dapat 1 mole of Cl minus gas, and with the right apa tu, you kena labelkan with the right label of your electron affinity punya enthalpy here, with the right value, right sign. Okay, baru 1 markah macam this whole thing. Lastly is dekat you punya markah, dekat you punya enthalpy of lattice lah. Okay, so this whole thing dia akan check, is this the correct enthalpy lattice punya thermochemical equation? Kita dah build before, you should know that enthalpy of lattice yang we have built before ialah bila 1 mole of a compound is formed from its gaseous ions, and gaseous ions itu pun 1 mole juga. You kena make sure this must be 1 mole, ada gas phase. You jangan sesekali, okay? Please lah, please don't forget, okay? Please don't forget to put the phase. Okay, don't forget the phase. Phase tu sangat penting. And then don't forget to letak atas arrow. Jangan lupa nak letak enthalpy with value and sign. Okay, jangan sesekali lupa. Because ada markah tu, okay? Ada markah tu sayang-sayang sekalian. Ada, ni pun macam satu markah, lebih kurang gitulah. Okay, so you tengok ni 1, 2, 3, 4, 5 markah je. And itu pun kalau let's say you dapat the correct thermochemical equation, the correct label, the correct phase. You tertinggal satu je, habis tak ada markah. Memang satu markah tu sangat berharga, okay? Lastly, you tunjuklah jalan kerja untuk cari the enthalpy of lattice here. Okay, so since that from the Hess law, okay, the target equation of your cycle is going to be the head of the equation. So the head of equation is going to be equals to the summation of all the enthalpies. So enthalpies yang terlibat ialah atomization of metal element, atomization of non-metal element, ionization energy, electron affinity dengan enthalpy of lattice. Okay, and this is what we need to find. And you masukkan je all of the information given, and then you make the enthalpy of lattice of as the subject pula. And then nanti you akan dapatlah enthalpy lattice you berapa with the sign, with the magnitude here, with the value, the correct value, and with the correct unit. Okay. Lastly, if you want to do the energy cycle of the Born-Haber in another way, so this is how it looks like. Okay. Where you put you punya compound kat sini, dimulai dengan formation, and then if let's say information tu kalau let's say dia bagi negative value, bawa turun bawah. Okay. Kalau let's say positive value, you buat apa tu anak panah tu ke atas. Okay. And then macam biasalah, dimulai dengan enthalpy of formation, disudahi dengan enthalpy of lattice. Okay guys, so let's look at this example. Disuruh kamu construct the Born-Haber cycle to calculate the lattice energy of CaF2. Again, CaF2 ni ialah ionic crystal solid. Okay, how do you know that it's ionic crystal solid? Because CaF2 ni terhasil daripada cation Ca2+ dan juga anion F-. Okay, so write down the thermochemical equation untuk lattice energy CaF2, di mana you tahu lattice energy of formation ialah when 1 mole of a ionic crystal solid is formed from its gaseous ions. We know that Ca, dia punya charge dia ialah Ca2+, and then it must be in gas form, in gas phase, alright. F in gas phase juga, tapi kalau you nak balancekan dia kat sini, since you ada 2 F, so you need to put 2 in front of the F-. Okay. And lastly, thermochemical equation tak akan lengkap kalau you tak letak enthalpy dekat bahagian kanan sekali. And this is something that you need to find. Okay guys, so before kamu nak construct Born-Haber energy cycle diagram, I highly suggest you untuk labelkan each of the thermochemical equations given in the question. Okay, you labelkan dia according to file cycle. Okay, you kena teka which one is belong to which enthalpies. So the first thermochemical equation, if you look at here, this is a metal elements kan, sebab calcium Ca. So if you look at here, this is metal element, daripada dia solid state dia jadi gas. That means I believe that dia tengah undergoes process atomization, tapi untuk metal element. Alright, and then next if you look at here, this is molecule. This is non-metal elements, but this is molecule because F2. This is atom. So I believe that this is enthalpy of atomization untuk non-metal elements. Alright. Okay, and then next ialah, if you look at here, this is a metal element Ca. Okay, tapi yang ni dia Tak ada charge. Yang ni ada charge, positive charge. Okay, that means dia tengah undergoes ionization energy. Okay, kenapa kat sini? Actually, untuk calcium ni, since that calcium, metal element ni, dia ada, suppose dia, kalau let's say dia form an ion, it should be in Ca2+. Okay, sebabkan dia suppose kena ada positive charge 2+, therefore dia akan undergo 2 kali ionization energy tau. Okay, so the first ionization energy bila Ca atom dia dapat single positive charge. The second ionization energy ialah bila single ion of Ca ni, calcium ni, bila dia release electron, dia akan form Ca2+. Okay, so macam ni, senang cerita macam ni. Kalau let's say any elements lah, non-metal ataupun metal elements, if let's say metal elements tu ditakdirkan untuk dia dapat charge 2 positive, 2+, that means dia kena undergo 2 kali ionization energy. Okay, untuk non-metal elements, in this case fluorine memang dia punya ion dia ialah F-, unless kalau you ada oksigen. Kalau oksigen O2-, therefore you akan ada 2 kali electron affinity. But in this case, since that you punya non-metal element fluorine you memang hakikinya ialah F-, so F single negative charge here, therefore you will only have 1 electron affinity untuk fluorine. Okay, daripada gaseous atom of fluorine, dia form a single negative charge fluorine. Okay, fluorine in gas phase. Lastly, I believe that this is enthalpy of formation. You must be weird. Kalau enthalpy of formation kena letak half kat sini. Kenapa dia letak half? Kenapa dia tak letak half? Okay, sebab ada sebabnya. So let's build our Born-Haber cycle later. Okay guys, so let us build the Born-Haber cycle according to file cycle. As usual, the head of the equation must be enthalpy of formation. Okay, kenapa Miss nak halfkan kat sini? Because I don't want it to affect this. Okay, because memang soalan suruh kamu cari compound. Dia bagi kamu ionic crystal CaF2. So kalau enthalpy of formation of CaF2, it should be 1 mole of a compound formed from its element. Element dia calcium in metal state, and also fluorine in non-metal state is in gas, so kena F2 lah. So dah memang balance, so tak nak kacau, memang tak boleh kacau. Okay, next ialah enthalpy of atomization untuk metal element. Tak ada masalah pun, daripada solid state kita hanya, kalau let's say kita atomizekan dia, dia hanya akan jadi in gas phase. Alright, and then next, okay, yang ni special sikit. Kenapa special Sebab information bagi apa? Information dia bagi half F2 gas, and then kamu akan dapat F gas, kan? Okay, information previously dia bagi tahu enthalpy of atomization untuk non-metal element ialah half F2, and then you akan dapat 1 mole of F atom gas. But in this case, I cannot halfkan this F2. Why? Because if I halfkan this F2, it will affect this. Okay, it will affect the balance chemical equation untuk enthalpy of formation. So I tak boleh kacau, I tak boleh letak half kat sini. So what can I do is, I can kalikan everything with 2. Okay, when I times everything with a factor of 2, alright, therefore I don't have to put half pun dekat sini. Okay, sebab kenapa? Just for the sake of kita tak nak kacau the balance chemical equation untuk enthalpy of formation. So therefore we need to sacrifice by kalikan enthalpy of atomization for non-metal elements with a factor of 2. Alright, so this gonna be the new thermochemical equation untuk enthalpy of atomization untuk case ni sahaja ya. Okay, so this is something special that you need to know. Another something special that you need to know ialah ionization energy. In ionization energy untuk Ca ada 2 kali sebab Ca kena form Ca2+, right? Okay, so sekarang ni after kita dah atomizekan calcium in solid state, kita dah dapat calcium in gas state. barulah kita boleh buat ionization energy. But you need to know, kita kena form sampai dapat Ca2+. So in this case, it is Ca+. So this gonna be the first ionization energy untuk calcium. Okay. And untuk dapatkan Ca2+, you need to do another ionization energy, the second ionization energy. Okay, di mana the second ionization energy, thermochemical equation dia ialah Ca plus 1 mole of Ca plus gas, and then you akan dapat Ca2 plus, kan? Okay, after that, kita proceed dengan electron affinity untuk fluorine. Okay, earlier electron affinity untuk fluorine pun before that dia kata, okay, information bagi daripada F in gas state, you akan dapat F minus, kan? Okay, tapi sebabkan you dah ter-affectkan this jadi 2F, so what to do? You kenalah kalikan dengan 2 juga. Okay. This is all semata-mata tak nak kacau. Tak nak letak half kat depan F2 ni. So, nak buat macam mana? Kita kalikan je lah dengan 2. Okay, so ni pun initially is supposed to be daripada 1 mole of F atom in gas punya phase. Kamu akan dapat F minus gas, kan? Tapi because of you dah kalikan dengan 2 yang this one, so dia jadi 2 mole. So that means you kena kalikan dengan 2 juga for your electron affinity. Alright. And lastly, barulah you dapat enthalpy of lattice. Okay, this is the balance thermochemical equation untuk enthalpy of lattice, where Ca2 pluskan dengan 2F minus, you akan dapat CaF2. Okay, so kita tak nak kacau yang ni juga, so that's why kita korbankan kat sini, kita kalikan dengan 2. Okay, for the last step, we know that from Hess law, the head of the cycle is going to be the head of the equation. The head of the equation is going to be the summation of all of the enthalpies yang involved. Okay, and you tahu you ada 2 kali ionization energy, and also you punya electron affinity dengan atomization energy untuk your non-metal elements, you kena kalikan dengan 2. So here it is, and you nanti make lah you punya enthalpy of lattice as a subject after you dah masukkan everything, substitute everything, and finally you will get your enthalpy of lattice energy is negative 2800 kilojoules per mole. Okay, lastly, you can test yourself by using this exercise. Okay, soalan ni disuruh kamu construct Born-Haber cycle untuk cari lattice energy for copper 2 oxide. Copper 2 oxide, I believe that copper 2 oxide terhasil daripada Cu2 plus dengan O2 minus dekat oksigen. So, I believe you will get CuO. Copper 2 oxide. Memanglah nama dia copper 2 oxide, tapi it all comes back from dorang punya ions. Okay, and since that copper ni dia Cu2 plus, that means mesti dia ada 2 kali ionization energy because dia nak form Cu2 plus, and also oxygen mesti ada 2 kali electron affinity supaya dapat form O2 minus. And please lah follow Miss punya step by step so that you can get the right answer. Okay, by writing down dia punya thermochemical equation for the lattice energy of copper 2 oxide. And the first step that you need to do ialah you need to label all of the enthalpies yang terlibat dalam file cycle. Okay, you kena teka which one is which, and then kalau dia bagi dalam ayat, you kena tulis, you kena build the thermochemical equation. Second last step, buat the file cycle, and then lastly barulah you boleh kira what is your enthalpy lattice of your copper 2 oxide. Okay, lastly, you bolehlah construct Born-Haber cycle untuk find the enthalpy of lattice for magnesium fluoride. Okay, magnesium fluoride ni is terhasil daripada Mg2 plus dan juga F minus. Okay, so it's an ionic crystal compound. Lepas tu I believe that since that Mg2 dia Mg2 plus, mesti dia ada 2 kali ionization energy. Fluorine ada 1 kali J electron affinity sebab dia nak form F minus. Okay, and nanti kamu just ikut je Miss punya step by step. Okay, so macam in this case it's quite it's not that easy, tapi kamu just kena dapatkan konsep je. Sebab kat sini macam kalau kamu tahu macam mana soalan tu kalau dia bagi dalam bentuk ayat ni, you tahu macam mana nak construct thermochemical equation for each of this. Lepas tahu macam mana nak label according to file cycle. So nanti kadang-kadang dia tak tanya tau lattice, dia tanya kadang-kadang second ionization energy. Biasalah exam ni dia kadang-kadang bagi yang susah, kita ajar macam benda konsep je. So once you have grabbed the concept, insyaAllah you boleh dapat jawab. Okay, so I wish you all the best. Thank you.